Hi folks, welcome to the second installment of PhotoView Fridays. It's a little bit late from when I had said I had hoped to get this next one up, so apologies for that, although at least I didn't wait till Friday, so maybe you could consider it early. I like early better than late, so let's say it's early. Let's see, a couple things before I get started on the topic today. One thing I wanted to first mention was the availability of the PhotoView 360 step-by-step guide. Rob Rodriguez has posted a forum post about that, and some people have seen that, but if you haven't, basically if you go to Rob's blog, robrodriguez.com, you will see a post about the availability of the book, and I think you can get pre-buy pricing now, so I think it should be ready to ship in the next week or so, hopefully. I don't know for sure, can't say for sure, but hopefully soon, and I guess you can order it now and get it hot off the press. So that's one thing there, and the other thing I'll mention is Rob put a post about SP3 enhancements when SP3 came out, and one of the neat things here is there was a guest post that Rob did for Javelin Technologies. If you click this link, you'll get to that blog post, and Rob goes into a lot of detail in this video here about all of the illumination controls in PhotoView and the surface finish controls. So it's very good video with a lot of good information. So I would recommend checking that out if you haven't already. So, first of all, thanks to those who watched the first episode and have sent some suggestions along. I am keeping track of them, and I am definitely looking forward to creating some more of these as we move along in the future. With what I decided to cover today is something that's come up a few times recently on the forums as well. There was a post about a week ago, maybe 2 weeks ago now, about how to align the camera with the background to set up a shot. And Alessandro posted this. He was basically looking to figure out how he can make this spoon look like it's over here. I actually covered some of this in some detail in this post, so if you had seen this and watched, I posted a video link here. Not right there. I forget where it was. Here it is. And I talk a little bit about the difference between cameras and the SolidWorks viewport. I'm going to go into that in a little bit more detail today. I thought I'd kind of explain how they work differently, why they work differently, and what it means to get the result you want. I will actually make one statement before I start, and that is that if ultimately you're really trying to get a top-notch render of an object with a background behind it, you would not typically use the environment, which is the thing that gives you the reflections in your models and your lighting. You would not use that as the thing to display as your background for a number of reasons. Primarily, the resolution is never going to be high enough to look that great. There's a number of reasons, which I think I'll save for a future post when I perhaps cover how to use backplates, real background images, to really make the model look realistic. That said, you can do this. Not only can you do it, but it does serve as a nice opportunity to understand the difference between camera features, the SolidWorks viewport, the environment, what it is, how it works, and so forth. So I thought I'd just go into this in some more detail today. So before I start with anything in SolidWorks, I thought I'd actually look back on the Visualization 101 presentation I did at SolidWorks World. I have done now for a few years. And there's a couple of slides in here that talks about cameras and why. So basically, oops there. Let's go right to that slide. Apologies here. So, yeah, the bottom line is if you're going to create something to look realistic, you should be using perspective. There's two ways to get perspective. There's perspective in the SolidWorks standard viewport, and then there's actual camera features. I would recommend camera features for a number of reasons, which I'll go over in more detail here. But the bottom line is the human eye does not see things in an orthographic projection. You design that way in CAD for a number of obvious reasons, being able to line things up collinear, and it's easier to create your design in an orthographic projection. But when it comes time to visualize it, you really want to use perspective. So a little note about something that's changed in 2011 with orthographic versus perspective, and that is the amount of the amount of the environment that is visible behind the model. What I have here is 2011 on the left, 2010 on the left, 2011 on the right. The top image in both of them is orthographic, the bottom one is perspective. I'm going to go in a little more detail about what ortho is doing and why and how it's odd. But what you will see happen is that if you were viewing something orthographically in 2010 and you bring it into 2011, it will look the same. If you're viewing something with perspective, whether it be the SolidWorks viewport, or with a camera feature, you will see it change, and it'll look like we've zoomed in on the environment, or you're seeing less of it. In reality, what you're seeing now is a physically correct representation of how much of that environment would really be visible with a real perspective camera set up in the scene. What you see in 2010 perspective or ortho, and you still see in ortho in 2011, is this extremely exaggerated perspective effect on the background. So keep that in mind as we talk about this, and hopefully you also understand why we're making this change. So imagine this sphere is is an imaginary sphere around your model, and the environment, which is giving you your reflections and your lighting, and you can optionally see it with some of the environments, is sort of going all the way around your model. I've got the bottom half here, but if it was mapped to this and you were looking out from an orthographic camera, it's essentially a straight line. So the result is you don't really see very much of that environment. The camera would not be visible to much of it. Whereas if you switch to a perspective projection, now you see a much larger portion of the environment. So in the previous slide I said, well, you turn on perspective and we see less of it. The reason you see less of it now is because this is realistic. This is an extreme exaggeration of what perspective would be. Just to visualize this another way, using a SolidWorks model, I have a sphere, a shelled out sphere with one of the environments spherically mapped to the inside, and I'm showing my camera feature here. This is the camera feature in an orthographic projection. Again, it's a straight line. Don't read into the width of these lines. These are just a basic, simple representation that, hey, this is orthographic, you're seeing a straight line. It's not representative of the amount of the environment you would see or anything like that. So this is actually a model. I've put the sphere, it's no longer an imaginary sphere, it's a real sphere with the environment mapped to the sphere the same way it is to the imaginary environment, or imaginary sphere. So I actually have a camera here, I'm viewing it in an orthographic projection. The result is that's what you would see. So it looks pretty bad, it's only a handful of pixels. It's actually, in some cases you wouldn't even make out any image, you would just see a few pixels, and the background would look like a solid color that just kind of shifted as you rotate it around. With a perspective camera, you can see our frustum here has perspective applied, and you can now gather how much more of the environment you really see. When we look through this camera on this model, we actually see a a lot more of the environment, and it's a much more realistic representation for the camera. So take a quick look at this in SolidWorks and explain it with just a little bit more detail. So I will go ahead and turn on one of the scenes that has the visible background, like the kitchen, and got this from the front, and you can see, let me collapse this. Again, I've got an orthographic projection of my model, but I have an extremely perspective projection of the environment, and it's quite odd, actually. Now, we did this years ago. We introduced these in 2008, so 3 releases ago, and it was just sort of a neat and cool way to be able to put your model in a realistic setting. And it's, it works well when you want to do something really quick, perhaps take just a quick screen grab or something. But when it comes to creating a realistic looking image, it's nowhere close to reality. So for this reason, as opposed to keeping the fake exaggerated perspective environment, when you switch to perspective or camera feature, instead of doing that, we put you in a more realistic view of the model. So if I turn on perspective, you can see I see less of the environment now, but the portion of the environment that I see is technically correct based on the properties of the camera that's looking at the scene. So that's one thing to understand. The next thing is to understand is about how this changes with the zoom controls. There was another post that just went up, I believe today. No, it was a few days ago. But Scott Bob posted this, and when Rob had read it, he pointed him at the previous thread where I had made the video that talked about all this. But essentially, even in perspective view in the standard SolidWorks viewport, when you zoom in and out, you'll see the whole environment does as well. So if you zoom way out, it gets kind of crazy. So what's happening here? This is what I showed in the other video. I'll show it again here. Let me add a camera. And what I'm looking at now when I'm editing a camera is this left viewport is the current camera being set up and how it is viewing the model, and the right viewport is the result of what that camera sees. So the main thing with zooming is that in the standard SolidWorks viewport, when you zoom, there actually is a camera. There's not a camera feature. There's no camera in the feature tree, but without an OpenGL camera, there would be nothing to see. So calling the camera feature a camera is a little bit misleading. There's always a camera. It's just that the camera feature gives you some more control, and you can have multiple cameras, so you can switch between them, things like that. So the standard SolidWorks viewport, when you zoom in and out, is essentially decreasing when you zoom in or increasing when you zoom out the field of view. If you look at the feature property manager for the camera, you see as I move this, it's changing the field of view parameters. So the result of changing the field of view is obviously more or less visible environment behind the model. With a camera feature, the default behavior when you zoom in and out, let me step back. If you weren't aware, you can add a camera. I'm going to say OK and then come back in here, but I'll say OK. Now I added a camera. By default, we don't put you in the camera, so you have to enable the camera. By default, it's locked. You can see when I click and move the mouse, it puts a little X up. But you can just right-click and unlock it, and now you can use this just like a regular SolidWorks viewport. But you'll notice when I zoom, the same thing is not happening. Let's take a look at the camera again. And what's happening here, when I zoom in and out, I can actually do it over here, you'll see that the camera is actually dollying. It's moving closer to the model or further from the model. So in that regard, the field of view stays the same, and the amount of the environment I see behind the model stays the same. So this gives you a lot more control. You can sort of scale one object relative to the other and perhaps achieve the effect that you wanted more easily. So that's how cameras work in SolidWorks. I thought it would be kind of good to look at the example that came from Alessandro, because it not only puts you through this workflow, it actually had a couple of other interesting things I thought would be useful to understand with the model. So I got the model. He posted it on in his post. Actually, the funny thing is, we have a I think politically correct we'd say opportunity for future product enhancement, because when I open it, I'm not actually seeing the kitchen environment. So this was done in Italian, and you can see it actually has the name kitchen background in Italian. When I edit, it correctly finds it now and displays it. So here's the kitchen background, and this was what Alessandro was working with when he wanted to place the spoon in a certain position. So as I did in the video, in that forum post, I basically said, let's add a camera and do it that way, right? So in practice, if I was going to do this, I might position it sort of relatively close to where I think it's going to be. In other words, sort of on this countertop here. I might do that. I might just switch to a front view. It doesn't really matter, because when I add the camera, I'm gonna do all the adjustment I need then to to get it where I need it to be. But I'll for this example, I'll go ahead and put it somewhere in this area. So I'll add the camera, and you can see we've now got the spoon looking as though it's sort of on my countertop there. So I can use the camera manipulator or the property manager with all the controls to move this around, change the target, do all this, but I can also just come over to the right viewport and use my standard mouse controls to do the same sort of thing. So it's pretty simple to get it lined up like it's looking, like it's next to the bowl there, and it's close to the right size. I don't know what would be perfectly accurate size, but something something like that. So that's all it really takes to get the camera added. Again, once you add it, you have to switch to it, and once you switch to it, it's going to remain locked. And actually, I use cameras all the time, and I will frequently add it, unlock it, then just do my positioning. So I'm happy with it, and then lock it again so I don't mess it up accidentally. So that's all it takes to get it lined up. Now the additional things I noticed here were I don't have a shadow, and that was making it difficult to really see, well, where, if a shadow was here, I could more easily tell, is it sort of in the right place. So this was just another interesting aspect of this particular model, and I thought I would use this example to demonstrate it. So basically, in SolidWorks Real View, the lights are cast by, the shadow is cast by the first directional light in the model. Well, I have a directional light here, obviously, but I'm not seeing a shadow. So I have my first instinct when I see that is that for whatever reason, the directional light has gotten into a position where it's not actually shining, in this case, down from the Y onto it, because if it was, there should be a shadow under it. So that was my first instinct. So let's look at the light, and well, it actually looks like it's doing a perfectly good job of shining from the top down. And as you can see, when I move it, you can see some of the highlights on the spoon moving as well. So it's coming from above the model. So what next? So then the next thing to consider is, where is the actual floor? By default, when you add a scene, we position the floor sort of relative to the model so that it will show up in the most natural orthographic projection underneath the model. Again, I don't know where this precisely came from, this model, so I don't know what's gone on with it. But if I wanted to see where the floor was, I just edit the scene. Before I did this kind of quickly so we could see the background, but what you'll notice is my floor is up above the spoon. This offset here is controlling that. So you can do a number of things. The first thing I'm going to do is just set it to 0 and see where it falls. And now you can see it's actually fallen directly below the spoon. Now obviously if I was going to be real picky, I would put a reference plane in here so that I had a plane that went from the back of the spoon to the front, and then you can actually position the floor by a selected plane. So if I was getting real picky, that's what I would do. For this example I won't, but this is really just to show you that your floor, once it goes above the part, will not catch any shadows. You need to be below the part. If perhaps I wanted the shadow to be down below, I could do that. So if we go back to 0 and go back to our directional light, we can edit that now, and now we can move our light around and we can see the shadow moving. So what I'm going to do is actually go back to my camera view, and I'm just going to take a quick peek at some of the objects in here, and I can tell most of the shadow is coming, from the window that's over on the left, looking at it in this direction, which means my shadow is going to fall a little bit to the right. That's probably good enough. And that's it. Well, that's not really it. If you want to render it with the shadow, hopefully you've already come to realize that lights are not on by default. They are off by default in PhotoView. Again, a number of reasons for that. I think I talked about that in my last video, but essentially the environment gives you all the lighting you need. So if I take a look at this preview, you can see I get a subtle soft shadow underneath it even without turning a light on. And that's a realistic shadow coming from the environment. If I wanted to exaggerate it, however, I could. I turn it on in PhotoView. Now, early on in, I believe, SP0, if this model was created there, it would be suffering from this. When you turn a light on in PhotoView, it doesn't automatically enable the shadows. That would not be the case any longer if it was created in current service packs. But if you edit the light, go to the PhotoView tab, see now I can turn on the shadow. There it is. It has sort of hard edges by default. I can soften those up, and now I'm all set. So that's how we get that in PhotoView. So I think that wraps up what I wanted to cover today. There's, as I said, larger picture, no pun intended, with actually all of this, is that if you really wanted to create a photorealistic image, you would not use the environment, this thing that's giving me my lighting and my reflections. You would not use that as your background. It looks pretty good, I guess, but it's never going to look as good as a static image. The key, however, is that the static image must also be of the same place, taken at the same time. A lot of factors, and it's not easy to do unless you have the right content. But it can produce rather dramatic results. So I think in the future I might cover that topic. It's probably off a little bit, but anyway, I hope that everyone finds this somewhat useful, and keep the suggestions coming, and I will hopefully get to the next episode in the allotted time frame, hopefully within the next 3-4 weeks. Thanks.